Yeah, hi. My name is Ivan. I'm a software engineer with experience over 8 years. For my career, I have developed over 200 different microservices in different companies, different startups. I built a mass mailing system. We could deliver over 15 million emails per day, and it was very easy to scale. So this is help of microservices. Now I work in Filipinos fintech company, coins.ph. So on Microservice Kitchen, I am a chef, and I am going to tell you how to cook them right. Let's talk about what is microservice architecture. This is an architecture when your system consists of a lot of different services. These services can be written on the different languages, can have their own database, they have separated deploy, and they have their own storage, like database, Redis, and the main they are talking through each other by intersection communications, like HTTP requests or queues. This is an example how monolith system looks like and how microservices looks like. And to better understand, and of course you should know that microservices aren't a silver bullet. You should understand why do you need them. Of course your system, maybe you don't need to scale it, and a monolith will be enough for you. And let's talk at first about monolith problems to better understand microservices. The first problem is a slow deploy. We have a big system, and it takes a lot of time to deploy. Unwanted tests on deploy. We should run a lot of unwanted tests. Maybe we have one changing and we should wait maybe 10-20 minutes, I don't know. It's hard to scale. You should scale the whole your system. And two main points. It's hard to find determined place, and scopes of modularity can be broken. Let's talk about these 2 points. When your application grows, it becomes harder and harder to find determined place. We usually fight with this trend. In monolith systems, we make our code more connected. We create new abstractions and models. And despite the scopes of modularity, sometimes the scopes can be violated, and it becomes difficult to find a proper place. So the microservices can help without, and they solve these problems. About these 2 last points, how Robert Martin said, we have a definition about solid, whereas S is single responsibility. It means your service should do one thing and do it well. So in microservices scopes are based on business boundaries. We can prevent services from growing out. Let's talk about microservices benefits. Independent deploy, independent development. Difference can work on different parts of the code, write them on the different languages, and they don't know about another services. Independent deploy. One change, deploy only one service. It's faster and safety. You run only this test which you have changed, and also of course some integrations tests. Scalability. It's very easy to scale only determined service, neither the whole system. When we have built a mass mailing system, we could we could scale two services like email building, email service, over 150 replicas, and it helped us to deliver a lot of different emails per day. Sustainability. One of the services is down, user cannot be affected. For like image scaler, and if it doesn't work, people cannot not notice them will be working. And get started fast. For example, if some newbies will come to your company, it's very hard to understand what's going on. They can work with a little service, and it will be very easy to understand what's going on. And of course, there are a lot of three cons. A little bit slowly. The concept of microservices is to use a network calls. Of course, it's slowly than to use one service in one ORM system, and more complicated infrastructure. You should your ops team, APS team should work with a lot of different services, monitoring them, and you need to support it. And one more problem is problem of distributed transaction. But this is a big, hard problem. We are not going to talk about it. And there are key features you should observe. The main, when you do microservices, you should have only one service, one database. You don't need to share context. Services don't know to need about implementation details. So one service, one database. For example, if you're going to change something in your SQL schema, some new migrations, if you change them, your services can be broken. So use only network calls. Now, the thing is infrastructure as code. Docker is your best friend. Don't try to run your Python locally. Try to repeat your production environment. Use Docker Compose and standardize your commands. Write some make file, write make up, make down, make test, and standardize these commands in each service. So if someone from your team will come to work with this service, it will be easy to understand how to up it, how to work with it, how to test it. And also, I think this is the main point, that you should have a base Python image. All application should inheritance of it. In this application, we usually set up wrapper for HTTP clients. So when you're talking through your microservices, you should write a wrapper here. It will proxy some trace IDs, some another information. Will have some time limits, some retries. Wrapper for working with queues. Of course, I think one people want to work with RabbitMQ, one with Kafka, maybe someone with Nuts, and you should choose one queue and write a wrapper for your system to work with it. Login library, migration script, UW, CGI settings, you should implement on all of this in the base image. And all of your services should inheritance of this system. So another point, only one door from a home. I mean, only one microservices should be available outside. It means here I have a user, he goes only to the API service, which is have endpoint to internet. He proxies his changes to the auth. Here we verify user's token, And after this, when we show that this is person is authenticated, we proxy his request to our services. Of course, there are two problems. API and auth services are main. If they will be down, all our system will be down. But there are a lot of benefits of this approach too. Also, a main point is infrastructure as code. Don't use cron jobs. Of course, in Kubernetes we now have cron job, but try to avoid them, because when you're going to test your system, to write some infrastructure tests, it will be hard to test these cron jobs. One service, one database. I have already said problems with this. And don't share Redis too. When you have some cache in Redis, don't cheat like this. And this is an example of how usually our microservices look like. You have a base service, as I thought. You have migration, queue worker, and UWCGI shells to work with it. And do you like to sleep well at night? Of course, I think you do, like me. So your services should be tested well. There are two different approaches. Yeah, of course, you should have unit tests, and there are two different approaches of testing service to service. One of them is to use mocks. Like Swagger will generate some mocks. You will write tests between each service with these mocks. But I think this is not very easy to do it. And the next approach is write a lot of integration tests. You should have another repository where all your system will up. You have one more Docker Compose YAML file. You should repeat your production or development infrastructure. You can set some times limits for some workers, so you can test it easily. And of course, this is a best place to write a Selenium test. You can easily just up your front end and run Selenium tests. Okay, that's all.
Do we have any questions for Ivan? Anyone? Yep.
Why do not share Redis?
Because this is like shared database. You will cheat with it.
Okay, but what is the impact?
What?
What is the impact?
Impact.
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 What are the trade-offs if I share Redis?
Yeah, because this is it's because sometimes because for this it's better to use a queues. So, and why don't share Redis? Because some changes will happen about some data structure, and you will never not know about it. Some another team which put some data in this Redis, they can change the name of variables of something like this, and services which will read from this Redis, they will never know about it. It will be very hard to find. I think this approach is good.
Okay, thank you.
Any other questions? No more questions? Okay, thank you very much, Ivan.
Thank you.
Just just while we get set up with the next laptop, if anyone wants a snack, there's some snack boxes around the corner. You can go grab them and have some water before we get set up. I think Richard's going to have a... It's Richard, right? Yep. And I think for those on the live stream, we're going to stop the live stream momentarily and turn it around. It'll start again.